So this is a nice, quite straightforward GCSE exam question on linear linear functions and linear equations. Very straightforward if you understand basically the whole idea of linear sequences. If you don't, then you're going to get confused. And when we bring up the examiner's remarks, we can see that this is exactly what happened. A lot of people just don't understand this area. So responses to this question were very poor. Without a table of values, which we'll come to in a moment, that's something that used to be provided, but in this year they just didn't give you this table to fill in. And without that to complete, many candidates simply plotted the point 2 minus 3 with one other incorrect point, and they drew an incorrect line. So what they did there, the misconception here is quite interesting. They took this y equals 2x minus 3, and they thought, well, 2 must be the x value and minus 3 must be the y value. So they simply plotted that and it all went pear-shaped from then on. But let's bring these remarks back. When candidates prepared their own table of values, so when they did realize that's what they had to do, there was a problem with the minus 1. So we're going to have a look at that. Also, it was rare for candidates to realize an error had been made when they made the error, and consequently this didn't give a straight line. Now what this means is that a lot of people just don't realize that this is a linear function, and of course a linear function is going to give you a straight line. If you don't realize that, then when you go wrong, when your values go beyond or go outside of that line, then you're just going to join up those lines. You're not going to get a straight line, and the examiner is going to pull his hair out, as seems to have happened here. Now, it was rare for candidates to realize an error had been made, okay, and very few candidates made a sensible attempt to work out part B, either because they didn't have a suitable graph to work with, or because they just didn't understand the need to read off their graph at y equals 4.5. So we'll have a look at that. This is to do with the line y equals 4.5, which they introduce in part B, crossing the line y equals 2x minus 3. Many candidates didn't realize that this y equals 4.5, where it crossed, must give them the y coordinate of 4.5, which they would fill in to their answer here. So, quite a bit of exasperation on the part of the examiner in their remarks there. People just didn't understand this question at all. Okay, well, let's try and understand it and see how we would tackle it. So what we've got to do is draw this function y equals 2x minus 3, and the very first thing we can do is we can say, well, the y-intercept must be minus 3, and that's because the on the y-axis x equals 0. So if x equals 0, that term there becomes 2 times 0, in other words just 0, just disappears, y equals minus 3. So we can immediately fill in the point here. We can just put a cross here, 0 minus 3, because we know our line is going to intersect with the y-axis at that point. Now, where is it going to intersect with the x-axis? Well, it's going to intersect with the x-axis when y equals 0. So when y equals 0, let's put when y equals 0, the expression 2x minus 3 must also equal 0. And so all we need to do is solve this equation. So what we've got is 2x minus 3 equals 0. We want that minus 3 to appear on the other side as a positive 3, so we add 3 to both sides. So we say now 2x minus 3 plus 3 eliminates the minus 3, and 0 plus 3 gives us 3 on the right hand side. And then if we divide both sides by 2, we eliminate the 2 on the left hand side, and we get x equals 3 divided by 2 is 1.5. Okay, so that gives us our x-intercept there, and if we're very careful, we ought to be able to draw a straight line through those 2 points between the values of minus 1 and 4. However, drawing a straight line between two plotted marks is not a very good idea. It probably will give you an accurate line, but it's better to have 3 points marked or more. And it suggests here for the values of x from -1 to 4, it does suggest this idea of a table of values. So what's a table of values? Well, if I draw my x and y like this, and then turn this into a table, okay, so just put a division down here. This is what we call a table of values. Now basically, we're going to put any values we want down here for x, and then we're going to plug that into our function and see what values of y come out, because y, remember, is a dependent variable. So what are we going to do? Well, we don't need to put x equals 0 because if we've already worked out that point, but I'm going to put it in my table anyway, and you'll see why in a moment. If I start with -1 though, so -1, and then the next value I'm going to do is my 0, then I'll do my 1, 2, 3 and 4, and I've deliberately made my table vertical, whereas very often in past exam papers they're horizontal, and that's because it reads better as coordinates. So you'll see what I mean as we do the first one. So taking x equals -1, plugging it into the function here, I end up with -1 instead of x, -1 times 2, that's -2, -3, y must equal -5 when x equals -1. Okay, we've already said when x equals 0, y equals -3. And I'm going to just point something out now. We should get, as our next value, -1. And that's because what we've got here is a common difference. In other words, it's an arithmetic progression. Now, you don't need to worry about this when you're actually answering this in the exam, but it's useful as we work through these to understand these principles, because misunderstanding was why so many people got this wrong. So we're going to expect a common difference of 2. Okay, you add 2 each time when you're getting your y values, but let's see if that's true. So when we substitute 1 into the function, we get 2 times 1, that's 2, -3 is indeed -1. If we substitute 2 in, we're going to get 2 times 2, that's 4, -3 gives us 1. So again, common difference of 2. Substitute 3 in, we're going to get 2 times 3, -3, it's going to give us 3. And we substitute 4 in, that's 2 times 4, it's 8, -3 gives us 5. And you can see why I've done it vertically now, because what we've got is coordinates: -1, -5, 0, -3, 1, -1, 2, 1, 3, 3, and 4, 5. So now we can put some of these, maybe not all of them, but some of them on our graph. For example, we'd definitely want to plot 4 minus 5, which is going to be here. And we want our far extreme, so the -1, -5, which is going to be here. Okay, just being a bit cautious. And we can see these are lining up nicely. So we can now draw our line through them. And there we have it. So we've completed part A. On the grid below, draw the graph of y equals 2x minus 3. Now part B is quite interesting. The line y equals 4.5 crosses the line y equals 2x minus 3 at the point B. So where's the line y equals 4.5? Well, let me just change ink colour here. Well, 4.5 on the y-axis is between 4 and 5, must be here. Okay, so I can plot that on the point here, and everywhere along here parallel to the x-axis the value of y is also going to be 4.5. So all along the line here. So I can draw a line horizontal, a horizontal line parallel to the x-axis and see where it intercepts with y equals 2x minus 3. Okay, so there we go. And we can see that it's intercepting exactly here. And so we now should have the coordinates of P, because this is the point P, okay, which is the intercept between this function y equals 2x minus 3. We should label it, I suppose, for completeness. So let's do that. Let's use a different colour here. So this line is y equals 2x minus 3. We could call that, I suppose, our first function, f of x. And if I change the colour of my pen, we'll call this g of x, just to differentiate it. G of x equals y equals 4.5. Now, do you remember in the y equals 4.5. Now, do you remember in the examiner's remarks, it says that in the answer at point B, we already know the y value. Well, that's, of course, because it must be 4.5, okay? Because nothing's changed. All along this line, it has to be 4.5. So we can immediately put the y value in, 4.5. And all we need then is the value of x at point P. Well, if we look very carefully at where it intersects, where the two lines cross over, and we go down to the x-axis, there we are. We can see that it's 3.75, or it seems to be 3.75. And that's all we need to do to get a total of 5 marks. But just out of interest, because we're looking at this question rather than trying to complete it in a timed test, another way of doing this, certainly not the way that's suggested, but another way of doing this would be to use simultaneous equations. So by simultaneous equations, what I mean is we've already got y equals 2x minus 3. We've now got y equals, the tail's a bit long anyway, there we go, y equals 4.5. All we've got to do is substitute y equals 4.5 into here, and we will get, or we could put them equal to one another. Let's do it that way. Either way, we'll get 2x minus 3 equals 4.5. So a straightforward equation. Okay. If we add 3 to both sides, as we did before, we end up with 2x equals 7.5. And if we divide through by 2 both sides, we end up with x equals 3.75. So just a quick check there to confirm that we've got the right answer. We must have got the right answer, because when we work out the simultaneous equations, we equate them to one another, we get this equation which we solve, which gives us the answer x equals 3.75. So there we are.